Welcome everyone to this tutorial entitled Openness in Radio Access Network Design in 6G, the ORAN concept. My name is Marcin Dryjański, and together with Adrian Kliks and Łukasz Kułacz, we will present the Open Fronthaul topic to you at this tutorial. I'm the co-founder of Remedy Labs, a spin-off of the Poznań University of Technology in Poland, and we are a research and consulting company focusing on wireless communications, Open RAN, 5G and beyond. We are also actively developing ORAN-related software in the form of xApps. A few words about my background. I've been involved in 5G development since 2012, acting as a work package leader in FP7 project. Later, I was working as a RAN architecture consultant at Huawei R&D office. I'm also a senior IEEE member, co-author of a book entitled From LTE to LTE Advanced Pro and 5G, published by Artech House in 2017. And I did my Ph.D. on radio resource management for LTE and 5G. Now, speaking of the tutorial itself, the tutorial will take around 3 hours and will be split into following 4 parts. In part number 1, we will set up a background, the transition happening within the radio access networks, and introduce Open RAN topic along with relevant organization. In part number 2, we will discuss the details about Open RAN, including its building blocks, architecture, and RAN intelligent controller. We will also introduce the concept of xApps and RApps, which will then be detailed in the following parts. In part number 3, Adrian will take over and will provide an overview of the Open RAN related use cases, ongoing trials and deployments, as well as discuss the design aspects of xApps and RApps, along with simulation results of selected algorithms. Finally, in part number 4, Łukasz will follow up on the xApp design with the virtual lab, including implementation, deployment, evaluation of an example traffic steering xApp. So I will be discussing part number 1 and part number 2, and then Adrian will take over in part number 3, and Łukasz will follow up with part number 4. So that's the plan. Let us now move to part number 1, that is an Open RAN concept. And let's start with a little bit of a background for the evolution of the wireless systems. Don't get into the details, just wanting to show some example aspects that will then lead and are important in the context of Open RAN. So every 10th generation, as we all know, there is every 10 years, there is a single generation of mobile wireless systems. So starting from 1G in 1980s up to 5G currently in 2020s. The important aspect here is that we are moving from the voice-centric networks, where we had one network for voice in 1G, 2G. Then we have a transition point in 3G, moving towards IP networks, but still keeping the voice type services. And then we moved to the IP-only network, then again a single network for all the different services within 4G, then brought, of course, the voice connectivity all the way over IP as well. And then with 5G, there is a new, let's say, aspect to it, where in 5G we are having all the different services in the, let's say, in the IP world. But the new thing about it is that there are very many services, each of them with different requirements, and each of them requiring a different set of features that we'll discuss in the later section. Another aspect here is that from 1G to 3G, we had different systems in different parts of the world, different names and different organizations supporting those. And from 4G beyond, we are aiming at a single system with LTE Advanced Pro, and now with 5G also incorporating the LTE Advanced Pro as part of the next generation RAN. And to summarize that, every generation from the first to the fourth had been designed as a simple, let's say simple in a quotation mark system, basically focusing on that specific aspect, on that specific service, and that was tailored to one specific application. Of course, there were some additional ones, but the main one was always one. And then when moving to 5G, we are transiting to the point where there are multiple of the different services requirements, but also there are multiple sets of features. And on top of that, there are different systems incorporated in that design, including the new radio from 3GPP, including NB-IoT, including LTE, including Wi-Fi, including now satellite systems. All of those merge within the area of 5G system. So speaking about 5G itself, because this is where OpenRAN is brought into attention and came into play, is that we have this complexity introduced. Let us speak a few words about those aspects. So we have the ITU triangle that pretty much everybody of you already have seen 1,000 times, but I just wanted to mark an important aspect here that already mentioned several different services, and different services have different requirements in terms of where are we put the focus on. So for example, for mobile broadband services, we have data rates and capacity being important. In machine type communications, the connection density is very important, but not much on the data rate or latency. And then we are moving to the third leg of the triangle, which is ultra reliable low latency type of communications. And that is focusing most of the latency and reliability aspects. And having those in place to be able to realize those, we need a lot of features and technologies in place, and this is why most of those have been moved within the 5G era, including millimeter wave, massive MIMO, flexible numerology, but also adding unlicensed access, getting in place D2D or V2X communication, so device to device or vehicular communications, but also like a networking concept, including slicing, including Cloud Run, CPU, OP split, as well as integrating the LTE from LTE Advanced Pro, let's say, version towards the new radio system. And in order to make that work, we need an automation and virtualization. That's why also self-organizing networks, automated networks, software-defined networking, and NFV have been also part of that design already. And on top of that, not only the different services, not only the different configurations, not only the different techniques or technologies, but also the different bands are being added, and the spectrum aspects are also very important here that adds to those complexity, including sub-6 gigahertz frequencies, or even sub-7 gigahertz that we know, together with the first time to having a millimeter wave or super 6G or super 7G, whatever you call them, but they are very high in terms of the frequency range, which changes the channel models, which changes the electronic components, and so on. Also, licensing has been brought into attention with multiple different licensing types under the single spectrum framework, which is, let's say, the licensed or licensed third or unlicensed spectrum in place. There are additional concepts that are also taken into account when speaking about the new generation networks, like spectrum sharing or network sharing. And the spectrum sharing, the different parts of the world have different concepts for those, including CBRS in the US, including the LSA that was available some time ago in the Europe or mostly in Finland. Then we have those German regulations regarding private networks, and so on and so forth. With this, we are going more towards the direction of private networking or local licensing or dynamic access to the spectrum, which then lead to yet another, let's say, level that adds that to the complexity of the overall system. On the other end, there are network sharing concepts popping up with more and more options available, like site sharing or multi-operator radio access network or multi-operator core network, and then ending up with slicing, for example, where there is a single infrastructure and different operators provide their services over that infrastructure. An important point here is that it, again, is an important aspect when getting into virtualized networks, when getting into the topic of dynamic, let's say, access to the resources. This is where it's important to have those automatic mechanisms to make that all work. So in the end, having a lot of different features, having a lot of different requirements, having a lot of different applications, having a lot of different carriers, functionalities, configuration options, technologies merged together, we are ending up in having a very heterogeneous network, which is then relating to radio resource management challenge for those kind of networks. So how we manage all those different features with license assisted access, like LTE Wi-Fi aggregation, dual connectivity options, relaying, D2D communication, bringing satellite on top of that, and having TDD versus FDD. All those require basically an innovation and a new way of managing those networks with automated and automation for the radio resource management to make that systems more efficient. So how are we progressing towards 6G or beyond 5G, let's say? So there is these two types of approaches. We already know that there will be 6G, but that also might be true for 6G as well, where one of the option is that the next G or the next generation is sort of bringing all the different technologies under a single umbrella, and then we'll add different features over time, different technologies, different spectrum portions, or that we move to the next G like in the previous generations. In our case, 6G has already started, and this conference is already discussing those kind of concepts. But in principle, we could move to the virtualized and software-based systems where new components are being added, and that there might be an end story with the breaking the G way of providing the next generation systems. So currently there is this transition point between the legacy monolithic runs with a single vendor closed interfaces also being provided by a single vendor, and those that were hardware based and have limited options for RAN sharing in terms of dynamic basically applications, towards the open networking also in the radio access networks, where those are hybrid networks having different vendors, having in place open initiatives coming into place like XRAN or vRAN or CRAN alliance, then ending up in ORAN alliance that we'll speak in a second. And the RAN virtualization is one of the important aspects here, where we put the base station or the RAN in principle functionality in the virtualized containers, and then enable the software-based networking also in the RAN domain, splitting the functionality and having more players in the ecosystem. So why is it happening right now? If you take a look back in the history, we had this discussion already in 1980s, 1990s, where the consumer softwareization came into play with distributed apps, when we had the Linux OS with external companies providing applications. Then we had the drop down of the compute power for enterprises in 2000s and 2010s, moving also for enterprises with virtualization, with the Linux-based open source, let's say, solutions, with cloud computing, with switches, and also the fixed networks getting softwareized, those switches and routers getting standardized, and also software-defined networking in the enterprise market and in the fixed networks. This is all also happening currently in the, let's say, 5G era and in telecom sector, where we have a drop of compute power costs, and the hardware, finally, hardware for the RAN gets standardized to commercial off-the-shelf solutions, where all the components of the base station, except of course the real hardware that is needed there, gets standardized and softwareized. So We are moving from the so-called closed RAN, where every element, all the different elements come from a single vendor, also run in core network, where we have a monolithic RAN architecture where pretty much both the antennas, the BBUs, and the core network functions and all of those come from a single vendor. From having a vendor-dependent roadmap for the features that are being added, and also a vendor lock-in in terms of evolution and costs, so that we are locked into an individual vendor or a couple of vendors there. Towards Open RAN, where first of all, it's software-based. We virtualize the functionality, put them on the commercial off-the-shelf, pretty much everything on the Linux and virtual machines. Where also the functionality is split into different parts, so remote radio heads and BBUs that are then further decomposed, that we will see in a second. That basically the aim is to enable multi-vendor system interoperability. The interfaces between them need to get standardized. We need to have an interoperability procedures and so on. That is then moving towards an open and disaggregated RAN architecture. So all in all, in principle, we are going into commercial off-the-shelf, which basically means we have the ARM or x86 processors or computers with Linux OS on top of that. And then all of the things get virtualized. So all of the radio protocols for the radio interface and the base station components get virtualized either through VMs or containers or Kubernetes pods. And those are then encapsulated into microservice-based implementations, and pretty much utilizing the IT, the well-known IT techniques for sysops, for CI/CD, so continuous integration, continuous development, are being added to this place to get those functionality virtualized, which then means they could be scaled in, scaled out whenever it's needed. And for example, depending on what's the amount of traffic that we are currently handling, or where we would like to save the energy and move one functionality from one place to another one, and also enable and provide new functionality in place depending on whenever it's needed. And because of that, a separate individual functionalities that are containerized, they could also be put in place independently or from all the other elements, which makes time to market very effective. So now we are moving from the, let's say, distributed base station, where at each of the site we had the BBU and the remote radio head, that then moved to the centralized RAN, where we had the remote radio heads over the Fronthaul interface, then centralized with a central BBU, where we got a pooling effect, where we could handle things more centrally, where we could allocate resources more efficiently to the different base station sites. In the first place, that was all of that was proprietary hardware with proprietary interface. At that time, that is, let's say, the Capri protocol. The main advantage here is that we have centralized BB processing, and that was already known in 4G networks. Then we moved to the vRAN, or virtualized RAN. The concept is the same. It's also sometimes called the cloud RAN. Basically, what it means is that the centralized BBU is now virtualized. So we put it on the proprietary software, but on a commercial off-the-shelf server. So the functionality of the base station in the baseband unit is now virtualized, but we still have a proprietary interface. We have still the proprietary hardware. The important point here is that with the vRAN or with the cloud RAN, we have the virtualization of the RAN functionality. Now moving towards the Open RAN, that is where we bring openness, meaning there is an open interface. We also get white box hardware for the radio units, and then for the BBU, we have the split within the central unit and distributed unit. We'll speak about this in a second, but to start with, there is a split of this functionality that is then developed by the particular entities. So with ORAN, we are speaking about openness, about programmability, and about artificial intelligence. So it's not only being open, it's not only having intelligence in place, it's not only being softwareized, but it's all of those together. So when moving from the traditional RAN, where everything is closed and you only have access to multiple parameters, but you don't see any, you cannot basically have different vendors competing here, moving towards the Open RAN, where first of all, the openness comes with having an open interfaces between different entities. Before we have those entities, they need the functionality need to be split into several of those. So that is the CU or central unit, DU or distributed unit, and RU or radio units that we'll speak in the part number 2 of that tutorial. But the most important part is that we have an open fronthaul here, interface between DU and RU that we didn't have before, and that's most likely the eCapri protocol. And we also have a standardized version of the communication between CU and DU with the F1 interface standardized by 3GPP. Even more important, we have an external entity, the new one, the orange one that we'll discuss in part number 2 in details later on, where it's called RAN Intelligent Controller, and that brings the possibility to provide native intelligence to the network from external parties. Now, important part here is that we have the disaggregation of the base station entities, that we have the open interfaces between those. So in principle, all of those different entities could be provided by a different vendor. And that we have the coupling hardware from software. So all of those except the radio unit is virtualized. And that we have this intelligent management by the introduction of the external entity called RIC, that brings the external vendors also to develop applications that will then be discussed in part number 3 and part number 4 of that tutorial. So all in all, with Open RAN, we are speaking about disaggregation of the base station to multiple components. We are speaking about open interfaces between those, and thus having the enlarged vendor ecosystem, because of all of the pieces can be provided by different vendors. We're speaking about decoupling hardware from software. We are speaking about intelligent management addition to the RAN domain. And then because of all those, we could end up in having lower capex or capital expenditures to develop those types of systems, with the aim of minimization of proprietary systems, but also to bring faster time to market, and then being able to provide those in virtualized manner, so to also save some kind of bringing automation, which then minimizes the number of people who need to work on the management of the system by hand, but just having a little bit more scalability. So it's not the segregation itself, it's not the coupling hardware from software itself, it's not the intelligent management itself, it's not open interfaces itself, but the Open RAN is all of those things together. Now, speaking about how we ended up in having those kind of applications up to this point. So it started with 2016, where telecom infra project was formed by the operators, by Facebook. And then in parallel, we had this xRAN forum and CRAN Alliance, who were working on the Cloud RAN and Open Fronthaul interface. Then we had some kind of first trials in Latin America that was not yet the Open RAN systems, but sort of a virtualized systems starting to pick up there. 2018 February is an important date for the forming of the formal, let's say, standardization body for Open RAN type networks, which is called ORAN Alliance, that was brought by xRAN Forum and CRAN Alliance. Then in 2019, in February, Rakuten started to deploy the first vRAN network on large scale and getting a lot of, let's say, providing the numbers on the networks being cheaper due to the automation, due to virtualization of the network and better scalability. Then we also have small cell forum enabling and getting into the field with their adaptation to the ORAN system with the interface between MAC and physical layer. Then we have the partnership between ORAN Alliance and the Telecom Infra project, so that the operators are now providing and feeding back the use cases to the ORAN Alliance to make it standardized. Then we had yet another body called Open Policy Coalition that need to work, or that works together with government and regulators to take a look on the system from a different perspective as well, to promote that there. And then the next releases of the set of specifications from ORAN Alliance are now being popped up, and then more and more plugfests are being coming into the place. Now, speaking about all those entities already, let's map them together. So all in all, regarding the relevance of the different entities and different organizations together within that ORAN field, we have the 3GPP that still is there, that defines the functionality of a base station, that is then taken by the ORAN Alliance, and some part of the features, of course, all related to the RAN area, including the management, including the separation between CU and DU, between the interfaces within the ORAN, within the RAN area, are then taken by the ORAN Alliance to produce a set of additional functionalities and a set of interfaces, and enhance the existing functionality of the base station to be able to support it within the ORAN area. Whereas all the other ones, the other features like core network and the UE perspective are not taken, so the ORAN Alliance taken subset of those that were delivered by the 3GPP standards. Now, without getting into the details of the abbreviations here, because we are having to, we'll discuss those in details in the next section. They produce additional entities, produce the different ways of implementation for those kind of networks. And at the output, we have a set of specifications defining architecture, procedures, protocols for the Open RAN system. That is then taken by the open source communities, providing exemplar platforms, taken those specifications from ORAN Alliance and implementing those in open source. So then there are two main bodies here. There is an Open RAN software community that will speak in a second, producing actually what the ORAN Alliance specifications guide them for, and ONF SDRAN, which is the Open Networking Foundation version of the implementation of the ORAN specs for the RAN intelligent controller together with exemplar xApps. We'll speak about those in a second. And then finally, we have a telecom infra project with one of the most important subgroup within the Open RAN group called RAN Intelligence and Automation, RIA, who develop the use cases for the xApps, for the applications for network automation, including SON or radio resource management or massive MIMO. So starting from the left, we have reference design with 3GPP and ORAN Alliance. Then we have the exemplar platforms implementing those, and then in the end, we have the use case development with the tip that is then fed back to the ORAN Alliance specifications, designing the bits and pieces for the protocols and procedures, and then those are implemented by the open source communities. Of course, the vendors are also implementing those, but the reference designs are there. Now, what the important aspect here is what are the different ORAN nomenclature names. So if you are looking at open space RAN, that means the overall movement for opening RAN. If we are speaking about O-RAN, that means ORAN Alliance, sort of formal specifications and architecture. And if we are speaking about open without a space RAN, so Open RAN, one word, that's a telecom infra project for Open RAN, where part of that is RIA subgroup. There are also CUDU subgroups to basically enable the actual deployments and proof of concepts being deployed. Again, there are additional entities like Open RAN Policy Coalition to promote the policies in the government and and regulators, and also there are like more commercial platforms working to provide the stores for the applications. Speaking about ORAN Alliance itself, it's working within 10 working groups. The working group number 1 focusing on the overall architecture and use cases and slicing. Then we have working group number 2 and 3 working on real-time rigs. We'll speak about those in the second part, but there are 2 of them. Then we have working group number 4 and 5 where the focus is on the open interfaces and enlarging the scope of the opening of the interfaces, also coming up from 3GPP, so X2 interface, F1 interface, where the aim is to enable full interoperability between different vendors. Then we have 3 working groups providing the definition and the requirements and the architecture for the actual platform where we would build the system. And then we have the xHaul, so transport network, providing the requirements for those in working group number 9, and working group number 10 is the one working on operation maintenance aspects of it. The important aspect here in general is that each working group is working on its own pace. So we don't have yet a formal, let's say, releases of specifications like we had in 3GPP release 15 or release 16. Each of those are progressing in a different manner. So we cannot say we are, I don't know, with the system, we are compliant to the ORAN Alliance release 1 or 2, because each of the specifications from the working groups have different numbers and different versions. They are not aligned with each other. Therefore, it takes time, and we are not yet there so that we have the fully compliant systems available, because for example, non-real-time rig is much less specified than the near real-time rig with all the APIs and things like that. So by this, it's important to note that that's something to keep in mind. OpenRun Alliance also provides sort of a virtual exhibition where you could have a virtual booth if you are a member of ORAN Alliance, where you could provide your own demonstrator or demonstration of the actual work that has been done that is compliant with ORAN Alliance specifications, where you have either yourself or the one company with another ones to provide the different aspects of OpenRun implementations with the demonstrator part, like Open Whitebox or Open Cloud, or showing how the open interfaces are working, or showing the different use cases from the algorithmic perspective. OpenRun software community is a collaboration between ORAN Alliance and Linux Foundation that is then providing different projects, and they actually have the releases of the software. In that case, there is the e-release, which is the 5th release of the software version. They are split into different projects, so each part of the ORAN system has its own project and developed open source implementation for a reference implementation of the different protocols like central unit, distributed unit, but also both of rigs, together with some exemplar applications that we'll speak about in the next part, and the SMO as well, where the onboarding of the xApps running on the non-real-time rig are possible. Also, those are complemented by simulation integration platform, so that those could be tested. SDRun is another open source platform where the aim here is to develop the open source but working near real-time rig that we'll speak later on. So I'm not going to go into the details right now. With exemplar applications for radio resource management or self-organizing networks, where the basic idea is to have the open source but available for proof of concepts and for the real networks, microNAS rig, together with those different xApps. So summarizing, let us have a look at the pros and cons of OpenRun. On the green side, which is the advantages, we are moving with OpenRun towards avoidance of vendor lock-in, where the aim is to have more companies to participate in the hardware and software development, to increase competition, having multiple vendors providing those, but also because of having different open interfaces, then the possibility is that we will have, even in a single network, different companies working together, or solutions from different vendors working together in a single network, enabling faster innovation by exposing those intelligence out of the let's say the actual closed entities from the base station. Reduce of the capital expenditure, because basically you are allowing or having the virtualized software or virtualized functionality on the commercial off-the-shelf hardware. All of those could bring savings, quick time to market, because you don't have to have the next full release of the software, but you can have by using microservice-based implementations and containerized solutions and software pieces. You could only work on individual elements. Network flexibility, because we could, by having those virtualized and using commercial off the shelf, you could put them on different places. We can combine them. You can switch off some of the compute power if it's not needed. And then depending on the use cases, whenever there is a need for lower latency, then you bring together the different entities, or you split them apart if you want to have more centralized functionality somewhere there. On the downside, the technology is not yet mature to the level where all the interfaces and functionality within Open RAN architecture are defined fully. We'll discuss those in details in the next part. Interoperability and integration, meaning that we are able to actually have two different vendors with two different pieces working together. Complex automation, because then you need to have some kind of mechanisms to automate the different software releases for the different parts. Security is an important aspect that is brought into attention, because we have wider security threat space, because we have external companies, we have new entities, we have the open interfaces, we have splitting the base stations apart. We have software, we have all the CI/CD concepts which are new to the RAN and that expands the threat surface. The important aspect here is if actually the price will be lower if you take into account that because of having those different vendors, you need to have some kind of integration, you need to have some maintenance, which will be different compared to the regular traditional way of implementing RAN, and whether the performance of those kind of networks will be better or worse or equal to what we have currently, because having a single vendor, then it can focus on optimizing details, bytes and pieces. If you have an open set of several different vendors, then the performance might be different depending on how you implement things, and if they are integrated together versus the open, how much the opening of the interfaces will bring value in terms of performance. In terms of the actual looking at the Open RAN currently from the different operators, the challenges again are seen in the lack of maturity for the technology, the plugfests that are needed, the need for interoperability testing, some kind of certification, cost of integration, and so on. Also the security ones. The question if the total cost of ownership will be larger and smaller, or can become the same, because again, we have less cost in terms of the hardware, and maybe because of the software, and we could have more competition. That's why the cost will drop down. But then on the other end, we have the integration cost for all of those different entities. In terms of monetization, system integration is one part where for sure the new entrants will be able to, or the entrants working on the integration, there will be some kind of monetization possibilities. because they are external to the vendors. Then we have network slicing as one of the important aspects due to its dynamic behavior, due to the possibility of automation, due to the possibility of adaptation of the resources depending on the slices, and so on and so forth. So those are the kind of discussions that are currently handled. So to summarize part number one, let us now summarize this part that we just discussed. Opening RAN with the Open RAN concepts allows for breaking the G way of so generation by generation type of evolution or revolution, and going into the feature-based evolution, because basically we are able to take one container, one part of the software, one part of the hardware to evolve this, and then adding new features will not mean basically we need to redesign the whole system. Open RAN brings the flexibility, disaggregation of the pieces of the base station, decreases vendor lock-in, but on the other hand introduces integration costs and security issues that need to be resolved. There are 4 or 5 major organizations that take part in the standardization and development of the ORAN types of systems, including ORAN Alliance, including TIP or Telecom Infra Project, Open RAN Policy Coalition, and ONF with the open source implementations. And ORAN Alliance standardizes the architecture, the use cases, the interfaces, and the building blocks, as well as the protocols and procedures for the different entities. And we will speak about those in part number 2. So with that, I would like to conclude that first part of our tutorial, and we will see each other in part number 2, where we are going to discuss the architecture and the RAN intelligent controller from the ORAN Alliance specifications. So thank you for watching. Thank you for listening to this part, and encourage you to go and listen to our second part, where we're going to go into the details of the Open RAN systems.